All right, everyone, so we're back. Today we're going to be working with graphing. So we're still graphing quadratics. But what is happening today is now we're just adding a c value. Okay, so our essential question, how does the value of c affect the graph of f of x equals a squared plus c? Let's make sure we get this definition down. A zero of a function is just an x value for which f of x equals 0. Okay, so that's just the quick definition. Make sure you get that down so that you got it. One thing that I basically just want to talk about here, you guys, is that the c value, all it really affects, and it kind of tells you a little bit more about it in this core concept here, all it really affects is whether your graph is moving up or whether it's moving down. So if you have plus c, that graph is going to be moving up. If you end up having minus c, or they just say it whenever c is less than 0, that graph is moving down. So let's say we had something like f of x equals x squared minus 12. Your graph would just be moving down 12 units. Okay, the shape of it's still going to stay the same, but your graph is just moving down. Let's say we change that so it was f of x equals x squared plus 12. That graph is just starting from this origin and it's moving up 12 units. Again, not changing a whole lot, just moving up and down is really all we're working on right now. Okay, so first example, graph g of x equals x squared plus 5. Okay, so what I want to show you guys first is I want to just graph the parent function. I want to graph this f of x equals x squared just so that we've got it there and it's easier to compare. Okay, so here's our parent function. I'm going to start at the origin. And here's kind of how I start thinking about graphing this, you guys. If I plug 1 or -1 into this parent function up here, this x squared, that's just going to be like my x value is 1, just kind of like we see here. And then my y value is 1. So I'm going over 1 and then I'm going up 1 in both directions. Now if I start thinking about plugging 2 in, like either positive 2 or -2, so I'm going to the right and to the left 2 units, and then 2 squared is just 4. So over 2 up 4, and then again over 2 up 4 because of that symmetry. So it's going to be the same on both sides. And if I just continue this pattern, so if I plug 3 in for x, I'm going to go over 3. 3 squared is 9. So over 3 up 9. And then kind of same thing, over 3 up 9. And I can just continue this pattern. If I wanted to go further and I wanted to use 4, my x value would be 4, my y value would be 16. If I wanted to do 5, it'd be 5 and 25, 6 and 36, 7 and 49. And, you know, the process just continues on. Okay, so now let's just go ahead. I'm going to graph this right here in purple. So if I start, I'm going to start right in the middle by plugging 0 in because 0 is just the easiest to start with. If I plug 0 in for x squared here, that's just going to give me 5. So I'm just going to go up here. I'm going to plot that point at 0, 5. If I start plugging 1 or even -1 in, those both just turn out to be 1. 1 plus 5 is just 6. So I'm going to be at 1, 6. And then again, through symmetry, that's just going to be on the same number, just on the opposite side. Now if I start plugging 2 in, so 2 squared is 4. 4 plus 5 gives us 9. So I'm going to be at 2, 9. And then -2, 9. Okay, so again, here's that basic parabola. The shape, you guys, nothing happened to the shape. It didn't get skinnier, it didn't get wider, nothing like that. The only transformation that you are going to say is that your graph moved up 5 units. That's it. That's all they are asking of you on this problem. Okay. I think what I'm going to have you guys do, so I have a couple of examples on this slide. I want you guys to do this one on your own. And honestly, now that I've kind of explained it, you can probably do this really without showing a ton of work. But I want you to get in the practice of showing the parent function, moving it down or up, whichever direction it goes in, and then telling me what the transformation is. So I'm just going to quickly talk about number 2, this one over here on the right. Again, I just went through, I graphed that parent function. So if you look at it, it starts at 0, 0. I went right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4, right 3, up 9, left 3, up 9. And then this graph, since it had a positive 3 to it, it just moved up 3 units. So again, just another example to kind of help you guys look at and get comfortable with. Okay, last example for this video, and then on the next video, I'm gonna do the, I'm gonna do 2 more examples, and I'm gonna do 1 in class with you guys tomorrow, or maybe you can try it on your own. Actually, that's what I'm gonna have you do. I'm gonna have you try it on your own, and then we'll go through the answers tomorrow. Okay, but I started off this problem again by graphing the parent function just so that I had something to compare it to. Because right now we're not totally sure with our comparison stuff, so we need to have the parent function there so that we can compare it to that parent function. Okay, so again, if I just start by plugging 0 in here, just because it's the easiest, all of this turns to 0. So my vertex is going to be at 0, 1. When I plug 1 in, or even -1, so here's 1. 4 times 1 squared is just 1, so that's 4. 4 plus 1 gives me 5. So that's going to be in either direction, so I'm going to be at -1, 5. And +1, 5. I just said that backwards. Oops. Now let's go ahead, let's take 2 and -2 and plug those in. So 2 and -2, when you square them, both turn into 4. 4 times 4 turns into 16. 16 plus 1 is just 17. So each of those turn into 17, and I can't quite fit that one on here. So I'm just going to continue. So I'm just going to graph my points that way. One thing that I do want you guys to make sure that you're doing, just getting in the habit of, make sure that you have these ending arrows on your graphs so that you're showing, you're signifying that this graph is continuing on forever in that direction, following this same pattern that you started graphing. Okay? All right, I am done. Oh, wait, no, I'm not quite done. Sorry. The 2 transformations. So there's 2 of them. Okay, one of them is that it moved up 1 unit. And then the second one, if you guys kind of notice, so like we look here at this parent function, the parent function is over 1, up 1, over 1, up 1. This new function is not over 1, up 1 anymore. So this time we have a vertical stretch. And then I am just going to say that it's by a factor of 4, because I believe those are things that you're going to start being asked throughout the next couple of lessons. So just make sure that you're starting to say by what type of factor your graph is being stretched or shrunk by, excuse me. All right, so I am done with this video. Make sure that you've got all the notes down and that you've tried all the extra examples, and then you can move on to the next video.